Oh, because I know some people weren't able to be in class, and because I know that most of what we've done has been sort of hands-on and me showing you a little bit about how to use the model, but mostly letting you guys take the lead. I wanted to give you this video to have something to study from, to show you how I see using the model, and to give you all of the different tips and tricks about how to use it that you might need for the quiz. So um, I'm on the complex turtle model, the one that includes mate scarcity and randomness, and has this box that you can open up over on the left-hand side with all the complex stuff going on. And that's the one you should probably study from. If you're in the model and you click on any one of these variables or connections, it gives you the information about those. It tells you the value that's inside it, or the formula that is used to calculate whatever it is. You don't have to know any of that. But if you happen to click on something, it can feel like you're lost because there's a box here that looks unfamiliar. All you have to do is click on a white space in the model, and it goes back to the window that you start with all of your sliders. So know that you can always get back to the home page essentially of the model just by clicking on a piece of white space in the model. And then obviously we can change the number of eggs, the juveniles, the adults. We can change these to any number. And if I were to ask a question about this, I would tell you exactly what to put it on, or I would tell you set it however you feel. Because we know, right, we played with this, and we realized that it doesn't change the outcome very much. It might change the overall number, but it doesn't change the way that the curve acts, and it doesn't change the overall number of turtles at the end of the model by very much. So these are probably going to be set, and then I will either tell you what to do, or you will just set them however you please. Once you have something set, right, the simplest thing we can do in this model is to go up and hit simulate, and it'll give us our simulation. It will always tell you the entire population size, all juvenile and adult turtles. This one right here is what it's counting. And if you want more than one of those, there's a few things you can do, right? You can compare things pretty easily. Once you have a window up and you want to make a comparison to something else, there's a couple ways you can do it. If this slider is linked, you can actually change the slider and it will change the model. So we can see what happens as you move juveniles, right? That line moves. Not very much, like we discovered. Or you can change eggs. That changes things a little bit more, right? That's one way. The other way is to look at multiple simulations. So we can unlink the sliders from this simulation window, and now we can do another simulation. It won't change this one, and we can compare the two. And these windows work just like an operating system. We can shrink them down, and they'll go down to the bottom and be there when we want them. Okay, so now we want to change this and see how road mortality changes things. So we're going to change it to 3% road mortality. Simulate again. And just to make sure, I'm going to unlink my sliders from this window. Okay, now I can click on this window, bring it up. And now we can compare. We can see that there's 13,000 turtles at the end, and this pretty shallow curve compared to 105,000 turtles, and a really steep curve over 100 years. We can also do something else really cool. So if we shrink these windows down, right, we can do this over a few different road mortality scenarios. We did 3, right? Let's do 5. We'll simulate that one too. Okay, and I'm just going to shrink it. We don't have to. These all could be up if we wanted, right? It just gets kind of messy, but they're all there. We can go up. This toolbox is so useful. We can go to compare results, and then we just select what we want to compare. Which window, 1, 2, or 3, do we want to compare? We want to do all 3, so we're going to select them all. What do we want? What primitives do we want to grab? This is confusing. We want all juvenile and adult turtles because that's our population size, right? And then we can compare them. And we can see what each looks like. We can even look at the end and see exactly how many there were in each line, which is really cool and powerful. So that's one trick. The other thing, I'm going to set road mortality back to 0. The other thing is this randomness, right? We can turn randomness on, and we see immediately that the line gets squiggly and we've got random things happening in our data. That is when we want to use sensitivity analysis to use the power of randomness to tell us how often something is going to happen, right? In that case, we don't use the simulate button as much. We use the sensitivity analysis. So I'm going to close this and go up to the toolbox again. This is super helpful. Go to sensitivity testing. And you'll never have to change anything in this box. I have it all set up for you. You never have to change anything. And it's going to plot the total population size, all the juvenile and adult turtles. And it's going to do it 100 times, and it's going to give us all of our confidence regions, and it's going to plot each run. But you never have to touch any of that. Hit run analysis, and it's going to run 100 versions of the model and give us a plot based on all of those runs. This plot is a little bit hard because we can't hover over it and get numbers, right? But it does tell us the confidence. How confident are we that if we ran this model in the real world, that our line would be inside of each of these bands? The green is 100% of the time. We know for sure that our line will be in between those lines. And that's mostly what we're going to care about. You can ignore this quantiles table. That's really hard to understand. I don't even want to explain it. This all juvenile and adult turtle runs is worth looking at because it is every single run. And we can hover over it and see what our highest number is, right? It does it from highest to lowest. So we can look for that light green color. Let's move this down so we can see it, hopefully. Yeah, we've got an awful lot. Yeah, you can see all of your data if you want to. So we know that the lowest number is 64,000 turtles. And the highest one is really hard to see because the list is 100 long. But we can see over here that it's about 180,000. That's useful if you want to compare different sensitivity analyses. So again, we can collapse this window if we want to, leave it down here in the corner, And now we can compare that road mortality. And rather than hitting simulate, right, we're going to go over to the toolbox, to sensitivity testing, don't have to touch anything, and it's going to run it with that road mortality changed. And everything else is the same, right? Okay, now we've got two windows that we can compare. This one, and if we want to keep ourselves straight, we can click this little pencil and tell ourselves that this is 0% road mortality, right? You don't have to do this, but it's a good way to keep yourself straight. And this one is, what are we at? 3%. Okay, so it won't plot them on the same y-axis, but we can look and say, okay, how much might these overlap, or do they at all? Right? The top of this one is 21,000. So if we go over here and look down here around 21,000 and go all the way over to 100 years, the top of the right-hand graph would be about here. So there's no overlap. We can be 100% sure, right, because it's outside that green bar, that if we ran this, if we measured this turtle population in the real world, the line for 3% mortality would be completely different from the 0%. Now, if we close that and try again, sensitivity testing, run it, right? Let's look at this one. So this is 1% mortality. This one, 100% of the time, is about 98,000. So if we go over here to 0% and look for 98,000, that's probably, this is 90, 120, so it's probably right in here. So we're going to go straight over. Okay, that is where the top of our 1% mortality 100% region is. So it overlaps by almost half. And it overlaps into the yellow. So we can be sure that about 50% of the time, those would overlap. That means that 50% of the time, these two models give the same answer. So, how much different is 0% road mortality to 1%? Well, 50% of the time they're going to be the same, right? That's how we can use the sensitivity analysis to understand what's really different. Because if we turn off randomness, remember, (1% road mortality without any randomness tells us that the population is going to be 50,000, right? And we learned in class that when we do 0% mortality, it's 100,000. That's 50% less, right? Oop. I did this wrong. See what happened? I had my sliders linked. I'm going to unlink the sliders and redo 1%. Okay. 1% mortality is 50,000, a little over 50,000, 52, right? 0% is over 100,000. That's a 50% decrease. But randomness tells us something. even though the mean of the model says that it's a 50% decline, if you run it with randomness, 50% of the time, 0% and 1% mortality look the same. So that's not as big a difference as it looks like in the real world. That's where sensitivity testing gives you a lot of scientific power. So that's how you use this model. And on the quiz, I'll tell you exactly what you need to set things at. So you don't have to worry about that. Just know how to use all of the tools. The simulate, only changing one thing at a time, and using sensitivity testing. If you want to use compare results, that's super powerful, and learn how to use it. It's quick and easy. But that's not absolutely required. You can do the same thing without using compare results. So that is everything. And I hope that it's helpful. Go ahead and ask me questions over email or come into my office if you have questions.